Given question, assuming smooth wall and floor, determine tension in the rope.
In this diagram, point A of ladder is in contact with horizontal fixed surface and point B is in contact with vertical fixed surface. Point G is the center of gravity point where 100 Newton force is acting in vertically downward direction. At point D, rope is connected to prevent the ladder from slipping and we have to find out tension T in the rope. We are going to use virtual work method. So we will give small displacement to the ladder so that this point B will move from B to B dash. So I will show here the new position of this point B. Now we will show the slipping of the ladder. And here is the new position A dash. Now if we observe, point A is in contact with horizontal fixed surface. So we have to show normal reaction at point A. So we will draw here one vertical line, that is NA, and in the same way point B is in contact with vertical fixed surface. So normal reaction NB is the horizontal line. Surfaces given are the smooth surfaces, that means there is no any friction. Now if we observe, from this point D we have to find out tension created in the rope. So we will say that this point of contact to this vertical surface is R. So here dr is the rope and we will find out tension T in the rope. So this point T is the original point and we will show the new position of this point D is D dash. I will show with the help of the horizontal line. So here is the new position D dash and here is the original point D. So this D to D dash is horizontal displacement and it is small displacement. So it is delta x and we have to find out delta x. Now if we observe at point G, force is acting. So this is the original position and here is the new position of this point G, that is G to G dash, and this is the vertical displacement. So we can say that it is delta y. We have to also find out delta y. Now if we observe at point A, reaction NA and at point B, reaction NB is there. But what is happening here? The ladder is slipping along this vertical line or vertical direction and this is the horizontal force component, so displacement is 0. In the same way, at point A, ladder is slipping along the horizontal direction and this is the perpendicular force to this horizontal, that is vertical component, so displacement at NA is equal to 0. So we have to find out only this delta x and delta y. That means we have to find out the position of this point D as well as point G. So how to find out this position? So I will consider this horizontal surface, or I will extend this horizontal surface as a x-axis and I will extend this vertical surface as a y-axis. Then point C is the origin. So we know that the values on the right hand side are positive, values on left hand side are negative, values in upward direction are positive and values in downward direction are negative. So this is the C as a origin, this is x axis and this is y axis. Now how to find out the position of D? So this distance D to R we will consider as a x. So I will write here x is equal to dr. So how to find out this length dr? So we will consider the triangle BRD. So in this triangle BRD we can say that sine of theta is equal to dr divided by dB. Now this dB, if we observe this distance AD is 1 and distance AB is 4. So dB is 3. So we can say that 3 into sin theta. But this point D is towards the left hand side of the origin. That means we have to use negative sign. So I will say that minus 3 sin of theta. So we can calculate delta x. So it is easy. So x into, that means we will differentiate with respect to theta. Delta x is equal to minus 3 cos theta delta theta. So we will get the dx. Now in the same way we will find out the y, that is the location of this point G along the vertical direction, because we have to find out delta y. So I will make here one construction. I will extend this point G along vertical line. Here is the point of intersection, that is point P. Now in triangle AGP we have to find out GP. If we observe this GP and BC, both are parallel to each other and this is the same inclined line. So this angle is theta. So in this triangle AGP we can say that cos of theta is equal to, so it is important, cos of theta is equal to this GP divided by AG. GP divided by AG. So GP, that means y. So AG is equal to, so AG, G is the middle point, that is 2 cos theta. So GP is equal to 2 cos of theta, and this is nothing but y. So this we can say that y is equal to, and it in the upward direction values are positive, so we will keep 2 cos of theta. So delta y is equal to minus 2 sin theta delta theta. So we will get this delta x as well as delta y. Now we will apply virtual work method. So for virtual work method, sign convention is the important part. So we will use sign convention for horizontal forces. We will use for this direction towards right hand side positive sign, direction towards left hand side negative sign. For upward direction, so for vertical forces, for upward direction positive sign, for downward direction negative sign. So this is applicable for both forces as well as displacement. So by virtual work method we know we have to take force multiplied by displacement. Now at point D, which is the force, so force is T and which is unknown. Now direction of T is towards right hand side, that is we have to take positive sign. So by virtual work method, I will take T multiplied by, now this delta x, so here displacement is D to T, D dash, direction is towards left hand side, so we will use negative sign, so delta x is already negative, so we will take as it is minus 3 cos theta delta theta plus, now we will take other force, so other force is 100 Newton, so which is in downward direction, so we will take minus 100 multiplied by delta y, so here G to G dash, so it is also in downward direction because original position is here, so we will take with minus sign, so here already delta y is having negative sign, so I will take in bracket minus 2 sin theta delta theta is equal to 0. So we will take delta theta as a common term, we will transfer to the right hand side and it will become 0. So we will simplify this, minus 3t cos theta, now this minus minus will become plus, plus 200 sin theta is equal to 0. So again we will transfer this term to the right hand side, so 200 sin theta is equal to 3t cos of theta. So this sin theta by cos theta is tan theta. So theta is 30. So I will write tan 30. 200 tan of 30 is equal to 3t. Value of t is equal to 38.49 Newton.